So now let's talk about modules. This is a fundamental concept in Python and in other languages. I'm sure you may have all heard, building on the shoulders of giants or something, that whole, using the work of those who came before us. So in the real world, people have been developing software for 60, 70 years. But obviously, as we've in the last, since the internet, even before the internet, they used to send out disks of software. But now since the internet, it's very easy to share stuff. And so when we're using Python programs and we want to use someone else's work to enhance our work, we use that. It's called a module. You can think of as a module as a library of definitions, either definitions of variables or constants or statements of code or function definitions, all kinds of fun stuff. And there's a number of them built into core Python. It is basically, and probably one of the most important. I think we can all agree that there are just some things a calculator does that you don't ever want to do in your head or write code for. In fact, I wouldn't know how to write code for sine. I don't know how to do a sine or a cosine or arc or whatever, those tangents and all those. I don't know how to do it. Or square roots. There's some hard code out there. And why should I write my own code? A lot of other people have already contributed a lot of functions and definitions to the math module. So for example, the value of pi. I'm pretty lazy, so I'm not going to go out and look up the internet and figure out what pi is and copy paste in there. I'm just going to put 3.14, but that's not really very precise. If I were using a scientific application and I really was using pi to be, something important, or if I'm working for an architectural firm and I need to know the radius of something, I really need my pi to be accurate, at least as accurate as we can get with a floating point number. Well, math module has a definition for pi, and it actually goes to much more depth. It has this symbol for pi, which if I just type in pi, there's no pi there, right? I don't know what pi is. So in order to use the math module, we have to import it. So you could think of importing it as saying, I want to use your library and whatever stuff you have in it. And now that we've done that, we put the module name in a period, and we put in the thing we're looking for, which is pi, and it gives us a fairly accurate, obviously pi goes a lot further. But remember, in floating point numbers, we have precision issues. We can only go so far. And this is as far as we can go for the value of pi. And so we use import whatever module we want. And then we use the module name. And then whatever symbol, whether that's a variable or a function, and we're actually going to do an example of a function in a minute. So we just did math, and that allows us to use someone else's work to help us. And again, these libraries, there's a ton of libraries out there that we could just build on top of, right? And so the math library already exists. It has that pi symbol, and now we can use it. And there's other symbols in there. E, the natural log, that's in there, 2.7. I don't even know really how to use that anymore. It's been a while since I've done my calculus, but that's in there. And there's a lot of other methods in there, and it's not doing it. There we go. So notice I hit the period and I left it alone for a second, and then it popped up this little window. And look at that. Arc, cosine, arctangent, ceiling, cosine, there's the E, exponent. You figure out something to an exponent. Floor method or function, infinite is infinite. There's a whole lot of, there's logarithmics in there. There's pi, pow. Well, we can make a number go to a power of another number. So 2 to the 10, what's that? Now we have the exponent one as well, but we could use pow as well. And by the way, you want to know something really big? Look at that, 2 to the 100. It's a really big number. That grows really fast. And notice this is e plus 30. I mostly did that example so I can explain e plus 30. That's scientific notation. This is 1.267 times 10 to the 30th. So that e to the 30 is just times 10 to the 30th power. Another function that's actually pretty interesting is factorials. Factorial 5 is 5 times 4 times 3 times 2 times 1. And this one really grows fast. This is one of those fast growing things, factorial 10. And then there's, oh, this one is huge. So you saw 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 3,600,000. Well, what do you think 100 is going to be? I don't know what that number is, but it's really, really big. So these are the kind of different functions that exist in the math library. It's a lot of pre-written definitions and functions that we can use in our own code to make our lives easier. Also, I've said this before to students, I'm not sure if I've said it in this class, but the more code you write, the bigger chances you are of putting a bug in your code. By using someone else's pre-existing code that we know works, which the math module is one of them, we can ensure that we're using quality code to build our own code from. So how do we know what arguments, the format of arguments you can pass to the method? So one way is to look at the help. So if I do factorial, sometimes it'll actually tell you what's supposed to go in there. It's actually really slow right now. Sometimes it works, sometimes it doesn't. But the other way is the internet. There's a lot of documentation on built-in math libraries or built-in modules that you can get to. And so you can just search up Python math factorial, and you can see, like I said, I'm sure it's all over the place on the internet because it's a built-in module. The internet's going to have the latest documentation for you, and that's how you're going to know. The other way you know is you think about math. How do I do a power? Well, that's a number to a number. How do I do a factorial? Well, that takes a single number. So some of it's knowing what's supposed to happen, and sometimes you just have to go look up the documentation. There's a lot of documentation for all kinds of programming languages on the internet now, which is better than the days when I learned to program and I had to carry around books that were this thick just to look stuff up. I used to have to carry on huge references for various languages. Thankfully, you guys have the internet, so it's not quite the pain it used to be. There's another useful module, and one that we're actually going to use today, called random. This module will generate random numbers using, or pseudo-random numbers, because computer is actually incapable of generating randomness. There is no such thing as entropy inside of the computer. However, there's mathematical algorithms for generating pseudo-random numbers, which basically mimic random numbers, and you can write them to be fairly good, where they won't repeat excessively. And so if I want to do random number generation, we can use a method in the random library called random dot. And again, it's going to hopefully load up the list here. And there's some things in here, but the one I'm looking for right there is called randint. Randint is going to create a randomized integer. And you can, I don't know if you can see it there. Sometimes, and apparently math didn't do it, but randint is doing it. It says return a random integer in the range bracket A, comma, bracket B. And that basically means they're both inclusive, so both endpoints. And so if I put 1 and 10 in here, and I'm not sure why I suddenly lost the ability to type in here. So import. I may have just lost the ability to type, period. Oh, wireless, not always good. Yep, I think I killed my battery. And we're taking a technical break. Well, I fix my battery issue. There you are. There we go. So import random dot rand int. It told me it took two numbers. They were both inclusive. And so this is going to generate random numbers between 1 and 10. And I run this a bunch of times. It's just generating random numbers. And you see a lot of the numbers. And notice it did include 1 and it did include 10. And so we can just generate a whole bunch of random numbers repeatedly. And yes, it does repeat because it's a small set, but you know, it's giving a pretty good distribution of different numbers. Obviously, we want more randomness. We use bigger range. So one example of a bigger range, or even a smaller range, we don't have the numbers between 1 and 10. We can do 1 to 100, but we could also do 100 to 103. It's going to include both numbers. So there's the 103. There's a 10. I'm getting a lot of 101. I'm trying to get 100. There's 100, but it's going to give me within that range, right? It's only going to be within that range. It's not going to give me numbers outside that range. Of course, we can actually store the random numbers. So let's do a random between 1 and 100. We can store it in a variable. It's just a number. In this case, it happens to be an integer because you can also do random doubles. There's another method that'll return a double. And we got the number 184. So random numbers, very, very helpful for us. In fact, we're going to be using them in a few minutes to make a little game. But modules allow us to pull in code that we don't want to write ourselves. Stuff that either may be too hard or, you know, that people have done a lot of stuff with. In fact, there's a lot of machine learning modules out there in Python, which is actually one of the reasons why machine learning in Python, and Python's got such a popularity recently. I say recently, the last 10 years, because both web and machine learning have a lot of libraries and a lot of modules that you can use, and you can pull them off the internet. Obviously, pull trusted sources,